Good morning everyone. So we're going to talk about auxiliary views and why do we need it and how we can construct auxiliary views. So previously we have talked about multi-view projections, and we know that the multi-view projections comes from a glass box, right? Comes from a glass box, and you open that glass box, you can get front view, top view, bottom view, right side view, left side view, back side view, and you only need to choose certain views that gives you the most information that you need. And most of the time we use the front, the top, and also the right side view, and typically that is enough. But sometimes those 3 views or the 6 views that we have from the glass box is not enough to give us the true length. So auxiliary view will show us the true length of an oblique line or the true size of an inclined plane. And in many cases, the auxiliary view will replace one of the regular views, such as the front, top, and side. So if you have your auxiliary view, you can replace it for your front or for your top or for your side. Alright, so an orthographic view that is projected onto any plane other than one of the 6 principal views is known as the auxiliary view. Now look at this diagram. This is the standard third angle projection, and we have learned about this in our previous lecture. We know that we have the front, the top, the bottom, the right, left, and also the rear or the back side. This is the flat plane or the flat projections, and you have 6 of them. But sometimes you cannot capture the true size of an inclined plane using these 6 views, so you need an additional view. So in a multi-view drawing, the true size and shape plane is shown only when the line of sight used to create the view is perpendicular to the projection plane. But what if it's not perpendicular? So this is a case where we have an inclined plane and our front, top, and right side does not tell us what the actual dimension of our inclined plane is. Okay, so oblique lines, inclined planes, and oblique planes are never shown in their true size and shape as one of the 6 principal views. So here, when you construct your auxiliary view, you get your actual shape and size of the inclined plane that we could not view over here or over here or over here. When you view it from the top and from the right side, you see that the size is not even the same because they are foreshortened. And you also cannot tell the true size from the front view because you only see the edge. So sometimes the auxiliary view is necessary. So a 3D view of this same object shows how the auxiliary view projection theory works. So you have your glass box, you have your object inside the glass box, you have your 6 views, you have your 6 views, and you have your inclined plane over here, and none of these views show you the actual dimension. So the inclined plane is never shown in its true size and shape in the 6 principal views. So how do you construct an auxiliary view? So you can imagine it, this is your line of sight. You're looking directly at the inclined plane, and you construct a plane that is perpendicular to your inclined plane. So if you look at this side and this side, I would say this is 90 degrees, it is perpendicular. Look at my cursor, this line and this line is perpendicular to each other. They make 90 degrees. Okay, so it has to be 90 degrees to your inclined plane. So how do we do it? You use the fold line method. An auxiliary plane is generated that is perpendicular to and hinged to the frontal plane or the front view, creating a fold line between the front and the auxiliary view. So what is a fold line? So you just create an imaginary axis over here which is parallel to your inclined plane. Okay, so you have your parallel line over here. This is called your fold line, and you will make another fold line over here, and you start to draw your construction line. So I'm going to show you the steps in a bit. Okay, an alternative to the traditional fold line method is the reference plane method. We're not going to go over this one. So auxiliary views are used to determine the true size and shape of features that would appear foreshortened in any principal views. The 6 principal views. The applications for auxiliary views can be grouped into the following 5 areas. Sometimes you need it for reverse construction to find out what is the true length of a line. Sometimes you need it to know the point view of a line. Sometimes you need it to know the edge view of a plane and also the true size of a plane. So this is just common sense. Anything that you can't see, you do the auxiliary view. Okay, so constructing an auxiliary view, the first step is to draw a fold line. And I told you, you make this fold line parallel to your inclined edge. So this is parallel. This is your fold line. You have the 3 dash, no, actually it's 2 dash and long dash, long dash. So it's very different compared to the center line or to the hidden line. So don't get confused with that. This is a fold line. And number 2, draw fold lines between the front and the top. So this is your front and this is your front and this is your top. So you make another fold line over here. So how do you know where to draw your fold line? So you have to have some value from the rear edge. So let's say I choose 10. So from the rear edge, I choose 10. So going down by 10, I draw my fold line. And from the rear end over here, I go 10 and I draw my fold line over here. Okay, so I need to draw my fold lines between the front and the top, and also from between the front and the right side view over here. The distance is from the edge, the rear edge, okay? Step 3, project the length of the inclined surface from the front view to the auxiliary view perpendicular to the edge view. Okay, so this is step number 1, and then step number 2 is drawing the fold lines like this, and step number 3 is drawing this line perpendicular to the projectors between the 2 views. So now you have like a projection plane for your auxiliary view. Step number 4, transfer depth of the inclined surface from the top view to the auxiliary view. So you transfer the depth. So from here to here, you measure it as x, right? So you transfer it over here as x, and this should be the same value for here to here. This is the distance from your fold lines, right? The rear edge, fold lines, the rear edge, fold lines. So you know that this is 10. You transfer that 10 over here. So you make like guidance line for your dimension later. Not dimension, for your projection plane. Okay, step number 5. From point C in the auxiliary view, so this is your point C. Let me make this bigger. From point C in your auxiliary view, draw a line perpendicular to the projectors. So you draw a line like this from C to B. Depth dimension y is transferred from the top view. Depth dimension y is transferred from the top view. So you want to know where our inclined surface starts, right? So it starts over here. You know that this whole thing is 10. Let's say y is 5. So you transfer the value 5 over here. So your inclined plane starts at, from here to here is 5. So it starts here. So now you have your AD and also your BC. And then you just connect the lines and darken it to show that it is a visible line. Okay, so this is an example of an auxiliary view. You can pause this video and look at it for your own reference. Oops. So I'm going to show you guys that there are different types of auxiliary views. So the first one is called the partial. So the partial is, you have your auxiliary view from this front, and this is the top, right? So you have your auxiliary view like this, but this is the only part where it is slanted. This guy is not slanted. That is why it looks funky. It's not slanted. So you only want to see this side over here, right? Which is this guy, the slanted part. So what you do is you just draw the slanted part, and you don't call it as your full auxiliary view, but you call it as your partial auxiliary view. Because why? You want to save time. You don't want to draw something that is unnecessary, because this guy is not slanted, but it is part of the auxiliary view. So if it's a full auxiliary view, yes, you have to draw it, but if you declare it as your partial, then you're good to go. So the next one would be half auxiliary view is used for symmetrical objects in which only half of the object is shown. For example, we have this end of, let's just call this a pipe. So you have this end of the pipe, and this pipe is fairly symmetrical, so you don't have to show all of the entire circle. So you just show half of it, and the person reading this, if you indicate it as half auxiliary, he would know or she would know that you just have to mirror this, and you would get the actual dimension of your slanted side. Okay? And of course, in very, very complicated cases where you have a lot of planes that are slanted and they cannot be projected on the 6 principal axes or the 6 principal views, you would have multi-auxiliary view. And this is for your reference when you graduate, and if you need this, you know what it's called, and you can Google it and find it out in the textbook or any helpful videos for you to do it. So here we have 1, 2, and this is not a slanted view, this is not a slanted view, but they call it a partial end view, a partial end view as well. And this is an auxiliary view, partial top view. So why do they have partial top views and partial end views and partial end views over here? Because if you look at this closely, when you look at it from the top, they are actually missing this side and this side. They just said, oh, let's not draw it because it doesn't give us any meaningful dimension. So let's just draw this as auxiliary view and this guy as auxiliary view. So we don't have to draw this in our top view. So they just draw this part as the top view. Because it is not a full top view, you call it as the partial top view. And the same case over here, you're not drawing the entire left side view. You're only drawing this side because this is the only flat side. You call it as your partial end view. In same case over here. And we're not going to cover revolution, so that is the end of auxiliary view.